Type SE cable, short for service entrance cable, is a type of electrical wiring often used to bring power from the utility company's service drop to the main service panel of a building. However, its applications extend beyond just service entrances, and it can be suitable for certain branch circuit wiring scenarios, including high ceilings, provided it adheres to the relevant electrical codes and standards. When considering wiring for a ceiling over 20 feet, several factors come into play, and understanding the properties and limitations of Type SE cable is crucial. Firstly, Type SE cable is typically constructed with a stranded aluminum or copper conductor insulated with a moisture-resistant, flame-retardant material. It also includes a reinforcing tape and an outer jacket, offering both mechanical protection and environmental resistance. The specific type of insulation and jacket materials can vary depending on the manufacturer and the intended application. You can find different configurations such as Type SE Style U and Type SE Style R, each having slightly different characteristics. Secondly, the National Electrical Code, or NEC, provides guidelines and regulations for the safe installation of electrical wiring. It's imperative to consult the NEC and local electrical codes to ensure compliance when using Type SE cable for any application, including high ceilings. Article 338 of the NEC specifically addresses service entrance cable. Thirdly, when running Type SE cable in a high ceiling, you need to consider the ampacity of the conductors. Ampacity refers to the maximum current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables, such as Table 310.16, that specify the ampacity of conductors based on their size, insulation type, and installation conditions. Factors such as ambient temperature and the number of current-carrying conductors in a raceway or cable assembly can affect ampacity. Fourthly, consider the voltage drop. Voltage drop occurs when the voltage at the load end of a circuit is less than the voltage at the source end. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The longer the wire run, the greater the voltage drop. For high ceilings, where the wire run may be considerable, it's crucial to calculate the voltage drop to ensure it remains within acceptable limits. The NEC recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. You can use voltage drop calculators or formulas to determine the appropriate conductor size to minimize voltage drop. Fifthly, mechanical protection is paramount, especially in areas where the cable may be subject to physical damage. While Type SE cable has a degree of mechanical protection, it may not be sufficient in all situations. If the cable is exposed to potential impacts, abrasion, or other forms of damage, it may be necessary to install it in a conduit or other protective raceway. The NEC specifies requirements for the protection of cables and conductors in various locations. Sixthly, support and securement are essential for maintaining the integrity of the wiring system. Type SE cable must be properly supported and secured at appropriate intervals to prevent strain on the conductors and terminations. The NEC specifies the maximum spacing between supports for different types of cables. You can use cable ties, straps, or other approved methods to secure the cable to the building structure. Seventh, consider the environment, including temperature and moisture. High ceilings can be subject to temperature variations and humidity, which can affect the performance and longevity of electrical wiring. Type SE cable is typically rated for use in dry locations, but some types are also suitable for wet or damp locations. Ensure that the cable you choose is appropriate for the environmental conditions in the ceiling space. Eighth, termination and splicing should be done properly. Terminating and splicing Type SE cable requires the use of appropriate connectors and techniques. Improper terminations or splices can lead to loose connections, overheating, and even electrical fires. Always follow the manufacturer's instructions and the NEC requirements for terminating and splicing cables. Use connectors that are specifically listed and labeled for use with Type SE cable. Ninth, grounding is very important for safety. Grounding provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. Type SE cable typically includes a grounding conductor, which must be properly connected to the grounding system. The grounding system should be installed in accordance with the NEC requirements. 10th, labeling and identification of the wiring is essential for future maintenance and troubleshooting. Labeling helps electricians and other qualified personnel quickly identify the purpose and voltage of the wiring. The NEC requires that all electrical circuits be properly labeled. You can use wire markers, tape, or other approved methods to label the Type SE cable in the high ceiling. The 11th, inspection by a qualified electrical inspector should be arranged before energizing any new or modified wiring. The inspector will verify that the installation complies with the NEC and local electrical codes. Correct any deficiencies identified by the inspector before putting the wiring into service. 12th, consider future access for maintenance and repairs. Ensure that the Type SE cable is installed in a way that allows for easy access for future maintenance and repairs. Avoid running the cable in concealed spaces or areas that are difficult to reach. Provide access panels or other means of access to the wiring. 13th, understand fire resistance ratings. In some cases, built-in codes may require that electrical wiring in high ceilings have a specific fire resistance rating. This is particularly important in commercial buildings or other structures where fire safety is a concern. Type SE cable may not inherently have a fire resistance rating, so it may be necessary to install it in a fire-rated conduit or other enclosure. 14th, always check for specific local requirements, because local jurisdictions may have additional requirements or restrictions on the use of Type SE cable. Always check with the local electrical inspector or building department to ensure compliance with all applicable codes and regulations. 15th, be aware of cable pulling. When pulling Type SE cable through conduit or other raceways, it's important to avoid exceeding the maximum pulling tension. Excessive pulling tension can damage the cable or its insulation. Use cable lubricants and pulling equipment to minimize pulling tension. 16th, consider the long-term durability of the cable. While Type SE cable is generally durable, its lifespan can be affected by factors such as exposure to sunlight, chemicals, or extreme temperatures. Select a cable that is appropriate for the long-term environmental conditions in the high ceiling. 17th, consider the aesthetics of the installation, especially in exposed ceiling areas. While function is paramount, the appearance of the wiring can also be a concern. Choose a Type SE cable with an outer jacket that is aesthetically pleasing and matches the overall design of the space. 18th, be aware of electromagnetic interference, also known as EMI. Electrical wiring can generate electromagnetic fields that can interfere with electronic equipment. If the high ceiling contains sensitive electronic equipment, consider using shielded Type SE cable or other measures to minimize EMI. 19th, understand energy efficiency. While Type SE cable itself does not directly affect energy efficiency, the overall wiring system can impact energy consumption. Use appropriate conductor sizes to minimize voltage drop and ensure that equipment operates efficiently. 20th, be sure to consult with qualified professionals. Electrical work can be dangerous, and it's always best to consult with a licensed electrician or other qualified professional when installing or modifying electrical wiring. A qualified professional can help you select the appropriate Type SE cable, ensure that the installation complies with all applicable codes and regulations, and perform the work safely and efficiently. They can also help determine if Type SE cable is actually appropriate for the intended application or if another wiring method is needed. Type MC cable is another type of cable that is often used in similar applications as Type SE cable.